Hello students, so now we are going to start with the second problem, which is again based on the Cartesian curve. So here we will have the equation in the terms of x and y, and we are going to find out the length of curve by using the formula. So let's see how to get solution whenever we have the Cartesian curves. So here we have to find out the length of r of the curve y equal to e to the power x, and guys, let me tell you that this is the exponential curve, and for this it is given that from 0 comma 1 to 1 comma e. So let me tell you how this exponential curve looks like, because in the previous video where we have covered the basic curves, there I have shown you how this exponential curve look like. So I'll draw it again. So generally exponential curves look like this. So I can say that this is a curve which is y equal to e to the power x. This point is 0 comma 1 because x coordinate is 0, and let's say this is the point which is 1 comma e. So what we have to do is we have to find out the length of the curve between these 2 points. So let's start. So guys, since the given curve is in terms of x, I can say this is y equal to f of x. So whenever we have a curve as a function of x, that time we use the definition of rectification or the formula of rectification, where we find out the dy by dx. So let me show you that in the previous video we have seen the different set of formula. So this is a formula which is applicable if your curve is given as y equal to function of x. So I'll use this formula because here it is given that y is e to the power x. So according to the formula, the length of curve is given by s equal to integration x1 to x2, so x coordinates of that curve, and under root 1 plus dy by dx the whole square dx. Now here let's find out dy by dx. So here I'll say the value of dy by dx is again e to the power x only. Now let's find out the length of curve. So s is given by integration. So let's take x coordinates. So it's from 0 to 1. Under root will have 1 plus dy by dx the whole square. So it means I have to square this term. So if I'll square this term, here we'll get e to the power 2x into dx. Now guys, let's integrate this function. So how to integrate this function? So guys, to integrate this function, I'm going to use the integration by substitution, because here you can see that under root we have the exponential function and we do not have any formula which looks like this. So I'll use integration by substitution, in which I'll put e to the power x as t. So here I'll say put. Now here if I'll find the derivative, I'll get e to the power x dx equal to dt. Now guys, if you observe here, we just have dx, we don't have e to the power x dx. So I'll send this e to the power x to the right hand side. So I'll get dx as dt upon e to the power x, and we know that the value of e to the power x is t. So we'll get value of dx as dt upon t. Now guys, one more thing, since we are converting this question from x to t, we have to change the limits also. So let's see what we get. So for x, the limit is from 0 to 1. Now let's say if x is equal to 0, if I put 0 here, then I'll get e to the power 0 as 1. It means the value of t is 1. Next, if x is 1, here I'll get e to the power 1, which is e. So the value of t is e. So my limit is changing from 1 to e. So I'll put all these values over there. So let's see what we get. So here we'll get s as integration 1 to e under root 1 plus t square. Now guys, e to the power 2x is t square because e to the power x is t. Now the value of dx is dt upon t. So here I'll write into dt upon t. Now as we have converted that function from exponential function to the algebraic function, we have to find out the integration of this algebraic function. But now guys, if you will observe here carefully, here we have u upon v rule, and in integration we don't have u upon v rule. That rule is there in the derivative. So the question is how to evaluate this integration. So again, I have to do few adjustments to get the value of this integration. So guys, what we'll do is, here I'll multiply numerator and denominator with under root 1 plus t square. So see here what we get. So here I'll say s equal to integration 1 to e. If I multiply the denominator with under root 1 plus t square, I'll get this. And when I multiply numerator with under root 1 plus t square, we'll get only 1 plus t square into dt. Now to get the answer, I'll divide this 1 by t into root of 1 plus t square, and then I'll divide t square with the same term. It means I'll divide numerator separately with the denominator. So here I'll get s as integration 1 to e. It's 1 upon t under root 1 plus t square dt plus integration 1 to e. Here we'll get t square upon t into under root 1 plus t square dt. Now guys, let's evaluate this first integration. So now again, to get the answer, what we can do is, again we'll use the integration by substitution. So by doing that, here I'll put 1 upon t as u, because by doing that I can convert this to a term for which integration is possible. So here I'll say put 1 upon t as u, therefore negative 1 upon t square dt is du. Now we have dt, so dt will become negative t square du. Here I'll say dt is equal to negative t square into du, and since the value of 1 upon t is u, I can say that value of t will be 1 upon u if I exchange this. So here I'll get dt as negative 1 upon u square du. Similarly guys, the limits will change. Now for t, the limit is from 1 to e. Now let's check it for u. So if t is 1, here I'll get 1 upon 1 is 1, so u is also 1. And if t is e, here we will get u as 1 upon e. So this will be the new limit. So guys, what I'm doing is I'm just solving the first integration. For second integration, at the same time, we'll cancel this t with t. We will get t upon under root 1 plus t square. And guys, here I'm going to use a property of integration which is like this. Integration f dash of t upon under root f of t dt is 2 under root f of t. So we have learned this property in 12th standard. So according to this property, the f of t is 1 plus t square. The derivative of this is 2t. Now I have only t in the numerator. So what I'll do is I'll multiply and divide by 2. So by doing that, here I can get 2t, here I'll get 1 by 2, and then in the function I can apply this property. So let's do it in the next step. So let's see this, what we get here. So in the first integration, I'll get s as integration 1 to 1 upon e. Here now 1 upon t is u, and under root, here we will get 1 plus 1 upon t the whole square. So here I'll write u upon under root 1 plus 1 upon u square. Next, the value of dt is negative 1 upon u square du. So here I'll write minus 1 upon u square into du. Plus, guys, as I said, I'll multiply and divide by 2. So here we'll get half integration 1 to e 2t upon under root 1 plus t square into dt. Now guys, here we'll get s as integration 1 upon integration 1 to 1 upon e. Next, I'll cancel this u with 1u. Here if I'll cross multiply, I'll get this negative sign. First of all, I'll take it outside. and here we'll get du upon, and this term will be under root u square plus 1 upon u square, and the root of u square is u, so this u will be cancelled with this u. So guys, we'll get only this term. Next, plus half, and here the value of this according to this property is 2 times under root 1 plus t square. So I can cancel this 2 with 2, and guys, don't forget to put limits over here, which is 1 to e. Now let's solve the integration. So here I'll say s as negative. Now this is the formula 1 upon under root 1 plus u square, or x square plus a square. So guys, we know the answer, it's log of u plus under root u square plus 1, and limit is from 1 to 1 upon e, plus here I can substitute the limit, so I'll get under root 1 plus e square, and if I put 1 here, the middle sign is negative, then I'll put 1 here, so under root 1 plus 1 2, so root of 2. So this is the value which I'll get from the second integration. Now let's solve the first integration. So here I'll say s equal to negative sign as it is. Let's take 1 upon e and let's substitute u by 1 upon e. So I'll get log of 1 upon e plus under root 1 upon e square plus 1. Middle sign minus. Next, log of, here u is 1, so I'll get 1 plus under root 2. So this is the value which I'll get, and negative 2 the remaining 2 terms as it is, so that is plus under root 1 plus e square minus under root 2. Now guys, here we can see that here I can apply the formula log a minus log b, which is log a upon b. So we'll apply that formula, and before doing that we'll simplify these terms also. So here if I simplify this, I'll get 1 plus e square upon e square, and the root of e square is e, so my denominator is common, which is e. So here we'll get s as negative log of 1 plus under root 1 plus e square upon e minus this term as it is and remaining 2 terms as it is. So now guys, the last step, here I'll apply the formula of log a minus log b, which is log a upon b. So we will get s as, so I'll write down the positive term first, so under root 1 plus e square, then minus root 2, then this minus, and the log of a upon b, so a is 1 plus under root 1 plus e square whole upon e, and into 1 plus under root 2. So guys, this is the length of the curve for the given function. So here we got the answer. So guys, I'm sure you understood how I got the answer for this given question. So similarly, you have to solve the integration. I know that this integration was quite tougher, and that's why I've selected this problem over here. So I'm sure that you have seen each and every step carefully, and just follow the same steps in the examination so that you will get the full marks. And with this, don't forget to share this video with your friends, because if you help your friend, they can also get good marks in the integration, because I know this is a very difficult topic for all the students who are studying in engineering. So keep following us, keep watching my videos. Well, here I am for you to give you the knowledge about engineering mathematics. Thank you very much.